Hi, welcome to Kruskal Algorithms, building minimum cost spanning tree. Here, the cable company wants to establish the network for 6 cities. We have to identify what is the minimum length of the cable is required for layout the cable network. 6 cities are given: Bhimavaram, Guntur, Gudivada, Vijayawada, Amravati, and Machilipatnam. Here, the distance between each and every city is given. So, based upon this, we have to identify what is the minimum cable length is required. So, for this, we can use minimum cost spanning tree to identify the minimum cable length is required for establish the network. So, here we can use Kruskal's algorithm to find out the minimum cost spanning tree. So first we will draw the uh, draw the network into a graph. So for that we have used that distance of each and every cities, and that city is used as a vertex, and the distance is used as a cost or weight for the edge. So after drawing this diagram, that is the graph, then we can use the Kruskal's algorithm to find out the minimum cost spanning tree. First we have to know the weight of each and every edge. So here we have sorted out that each and every edge based upon the edge cost. So here we have used ascending order, so all the edges are ordered in the ascending order, so based upon the city's distance. Here each and every city is taken as a alphabets here. So now first, we have to select the minimum weight edge from the given network. The minimum weight edge is here 2, that edge 2 is selected as a first edge between E and D. So now the edge is going to be added in the forest. In the Kruskal algorithm, we will select the minimum weight edge, then that will be added into the forest. So now the E and D is selected. So now we are adding into the forest. Then select the next minimum weight edge. Here the next minimum weight edge is 3, which is going to be selected. Then when it is selected, we should check is there any cycle is forming due to adding this edge into the forest. No, it will not give the it will not produce the cycle when it is adding into the forest. So we can select this edge as a safe edge. Safe edge in the sense minimum weight edge, and it should not form the cycle as per minimum spanning tree property. Then next minimum weight edge is here we are having 2, 4 available. Okay, A and E, and the distance between C and D. So you can select any one of the edge between these two. So now first, we will select the C and D. C and D. So we have to check is there any cycles forming due to adding this edge into the forest. No, it is not creating any cycle. So we can select this edge and add into the forest. So now we have added that edge into forest. Then next edge is a between A and E. So here we have to select that. When you are selecting this edge, is it forming the cycle? No, it is not forming the cycle in the given spanning tree. So we can select that edge and add into the forest. So now we have added that into forest. So now next minimum weight is two fives are there. So B and C, the edge between E and F. So when you are selecting the B and C, which is forming the cycle, so it forms the cycle, it is not satisfy the minimum cost spanning tree property. So we have to remove this edge. We should not select this edge to spanning tree construction. Then you can ignore this edge. Then next one is the edge between E and F. Now the E and F is selected, so which is not forming the cycle, so it is satisfying the property, so we can use this edge. Then is there any vertices are not visited? So all the vertices are visited, so that is the algorithm here. So we have to visit all the vertices and all the vertices to be connected. That means all the cities to be connected, so all the cities are connected with the minimum cost, I mean minimum length of the wire. So the length of the wire is needed to connect all the cities are now 18 units of wire. So we need 18 units of wire to connect all the cities as per the minimum cost spanning tree algorithm. Thanks for watching.